So today's our next topic is light detectors, another application of MOEMS technology. Diffraction is a phenomena which implies that the wavefront of a propagating light wave bends in the neighborhood of obstacles. Let us discuss the diffraction phenomena based on single slit as shown in figure number A and double slit as shown in figure number B, single slit interference. If we consider that diffraction through a single slit, then the properties of a system are completely dependent on the lambda by A ratio, where lambda stands for the wavelength of a light and A is the aperture of the slit. The mapping of the intensity pattern some distance away from slit consists of bright and dark fringes. The angle at which dark fringes occur is given by sin theta is equals to m lambda by A, where m can take any value from 1 to n. But theta is almost equivalent to the theta dash is almost equivalent to sine theta, and which gives tan theta is equals to y by d, determined only by the ratio lambda by A. In the middle, m is equals to 0. A central bright fringe will be observed, and it is the largest bright fringe. For double slit configuration, the situation is different in the sense that condition for maximal points instead of minima as in case of single slit. In single slit, we are considering the condition for minima, but in case of the double slit configuration, we are checking the condition for maximal points, where y is equals to md lambda by A, where d is the separation between the slits or grooves. Now coming to the figure, this figure number A, where you can see that single slit, and in figure number B you can see that double slit. So here y is equals to m lambda by d, where y is the deflection or displacement at which minima occurs, d is the distance at which observation is carried out, lambda is the wavelength of light. Note that the intensity, a diffraction grating is a set of parallel slits that is equivalent to obstacles that are placed or alternatively used to disperse or bend the light as shown in this figure. Then this is the incident wave front, incident plane waves, and these are the zero order, order 1 and order 2, where m values are ranging from 1 to 2 in this side. In diffraction grating, there exist many slits. Since diffraction grating deals with the light signal, it is an optical device. It is primarily used to observe the different wavelengths or colors contained in a beam of light. They are also used to separate the dense wave bands. The gratings allow efficient diffraction at grazing incident angles. There are specific directions along which the light waves from the different openings interfere with each other in phase, and in these directions the light intensity is observed as maximum. The specific directions along which the intensity will be maximum depend on the wavelength of the light waves. Since the light is composed of many waves having different wavelengths, the direction of propagation will be different for each wavelength. As a result, a specific wavelength can be separated or detected by the use of diffractive grating, hence the name light detector. The intensity of light at the screen is proportional to the number of slits in the grating. MEMS technology based diffraction gratings are rather called nano diffraction grating. NDGs are obviously MOEM devices. The device consists of thousands of narrow and closely spaced parallel slits. The NDG shown in figure has a depth and width of the range 395 nanometer and 295 nanometer respectively. Now we'll discuss about the optical switch. Micromirror based MOEMS optical switches have drawn attention in optical networks since long. The switch is based for regulating light beams. By using these switch, light can be directed in the same direction or in another according to the requirement. There are mainly two types of switches based on the way the mirrors are activated. They are interception type and rotation type. The former type uses multiple mirror requiring large linear actuation and design is very complex. The later type of switch is called torsional mirror micromirror type and uses single mirror requiring large angular actuation. So in case of optical switch, that this figure number A shows beam interception type where we have fibers, lens, mirrors, actuation direction. This is beam rotation type and this is light can be directed in any direction. The micromirrors can route light signal from and to any input-output optical fibers of 2D or 3D array. This suggests another way of classifying the switches in terms of number of input-output ports present. Accordingly, there are four types of switches, namely single input, single output, single input, multiple output. Regardless of their type, the switches are activated using the principle of electrostatic actuation. Magnetic actuation based optical switch will be discussed in the next chapter. Figure shows a simple 2D single input multiple output optical switches. It has one input port and four output ports. The incoming light signal can be directed to any of the output port that is connected to the optical fiber through the microlens arrangement. If the light signal is required to be directed to the optical fiber number 2, then the corresponding motor M2 must be activated by the electrostatic actuation. Similarly, if the light signal is required to be directed to the optical fiber number 4, then the corresponding motor M4 must be activated. Some optical switches are based on a tiny pivoting bar with a gold-plated micromirror at one end that fits in a tiny space between two optical fibers lined up end to end. In the off state, the micromirror rests below the cores of the two fibers, allowing light signals to travel across the gap from one core to the other. When a voltage applied to the far end of the bar helps to lift the mirror between the fibers, where it reflects incoming light rather than permits its passage. The torsional type switch consists of a torsional micromirror and corresponding electrode. The micromirrors and electrodes are fabricated on separate substrate. The electrodes are situated on ceramic layer. Special self-alignment mechanisms are designed for assembling the mirrors and electrodes. If a bias voltage is applied to the electrode, the mirror is attached by the electrode and tilted. The incident light thus can be reflected and redirected. The mirror is designed to tilt around X and Y axis. So here figure number A is the 2D single input multiple output beam interception type optical switch, where you can see that there are my lens, micromirror, fibers, motor, M1, M2, M3, M4. Here in figure number B, M2 is activated by the electrostatic actuation. Here M4 is in figure number C, M4 is activated by electrostatic actuation. So this is the complete schematic diagram of micro optical switch with two torsional mirrors. Here then on this mirror no voltage is applied. On this mirror electrostatic voltage is applied through electrode. This is the ceramic plate. Thank you. That's all about the unit number 6. Now we'll continue in the upcoming video lectures with the unit number 5.